Hello everyone, so today we're going to be doing some introductory binary exploitation challenges just to help members get started, if they need a little boost. We're going to be doing this on PicoCTF, specifically these PicoGym challenges. I think PicoCTF is probably one of the best places to get started. They also have this web shell that you can use. Uh, you can see here. This is really good because, especially for binary exploitation that uses the terminal, I believe a lot more than the other ones. Uh, when I was getting started, I had to set up a virtual machine because this is it's not really that great to do on Windows. And the fact that they just have a terminal here that you can use is pretty nice. Because these are PicoGym challenges are retired problems. These are just for practice, but if you're looking for the thrill of a competition, you can go to CTF time, upcoming, and you can see these upcoming challenges. To be honest, I don't know any of them, but I'm sure you could just sign up for one, hop in, and learn hacking. Okay, so let's get started. Which problem do I want to do? Let's see here. The buffer overflow. Everyone gets started with a buffer overflow, right? And you can see here they're saying smash the stack. Let's start off simple, blah, blah, blah. Programs here, sources here, and netcat is here. So basically how this thing works is that there's a computer uh, hosted by the Pico CTF people. It's running the program, and you just want to exploit the program. They give you the program in this situation, which is really nice. So first off, let's just try out that netcat and see what happens. So you see here, paste netcat input. So it's asking us for input, and if you're doing a binary exploitation problem, there's almost always two things you do whenever it's asking you for an input, right? You can type in a bunch of letters like this, A, over and over again. Basically, when you do this, what you're checking for is a buffer overflow. And if you don't know what that is, I think PicoCTF has uh, a, a whole like book on that. And so it's pretty descriptive and it's good. And we can see that something's going on here. Program exit now. Okay. Yes. So I guess something suspicious happened. I'm not sure. Yeah, let me try that again. Type in a bunch of A's. There we go. So you can see that just by tapping in a bunch of A's, we find that it gives us the flag. I don't know why I did that the first time, but maybe it was like just stalling for some reason. And yeah, so we found the flag. Easy. But I want to explain a little bit more. So let's say nothing happened, right? Yeah. Basically, say you just exit it normally, just like I said here, program will exit. That means nothing happened. So second thing you would do in that situation is you check for a format string, which is here. And once again, and if anything suspicious happens, you will see a bunch of like 0x, blah, 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 like a bunch of values like that. And that's how you know that it's a format string vulnerability. Again, if you don't know what that is, PicoCTF also has a book on it. I'm not exactly sure where, but if you're on our cybersecurity, hacking, and digital security channel, Discord, you can see it's in the resources section. Okay, so buffer overflow 0, done. We could, sure, yeah, yeah, okay, I'll do that. So because this one we hopped straight into the netcat, we didn't need to do this, but basically in this situation they give you the program. So this is the compiled program they give you. Okay, stop being annoying. Okay, so ask for input. So in this case we're running it locally, right? And uh, if we do the same thing we did, we see it types out a bunch of A's, and that's because that's what the flag was. Okay, so that's the compiled one. That's the binary. And they also give you the source in this case because they're extra nice. And we can have a look at that. vuln.c. And this is the source. So uh, basically how I like to think about it, the source is like the human readable section part of like a program. And then when you compile it, uh, the only thing you can read is the assembly because that's what the computer reads, right? So it's not that human readable. And yeah, so they're being extra nice here by giving us the human readable form. And if you just scan through, you can see the the main thing. A lot of this, if you don't understand, it's okay, it doesn't really matter. But the main thing you want to see here is the gets. And that's the holy grail. You see a gets 99 times out of 100. That's a buffer overflow. Uh, and for the format string vulnerability I was talking about, you would see like a printf, like something like here, and then you can see how they did a %s. I believe you do a %p instead. You type out the like an address, I believe, of a variable, and then so that's how it leaks information from the stack. Yeah, so if you do %p of your user input, that's how you get a format vulnerability. But yeah, I'm getting a little bit off topic here. Main idea, look at the guts. You see a guts, you're good. Okay, so let's get out of here. Should probably make another folder. So before we do that, so we did this. Let's see what are the hints. Okay. Oh yeah, should probably do a man gets. That's right. Man stands for manual, and then gets. We can read out what it does. It's deprecated. Yeah, I think that's how it's pronounced for a good reason. Yes, so you see this description. Never use this function. Why? Because basically what gets does is that here you can see here. Uh, gets will write a value into the stack or the buffer on a stack, except as they say here, without knowing the data events, how many characters gets will read. It does not check how many characters is going to go in, right? And so if you type in a bunch of letters like we did, it's going to write more than it's supposed to. Just in case you're interested, fgets. This is the safer version because I think it checks it or it does something, whatever it does. But yeah, okay, keep me out of here. Let's next problem. So buffer for 0. What do I want it to do next? Yeah, let's do buffer overflow 1. Keep it consistent. So if you have a instance going, let's just restart that. And also, I believe you went to our meeting. This is the problem I did. Yes, I think so. Yeah. So control the return address, blah 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 blah. Return to the flag function in the program. Okay. This one you're gonna need to know a little bit more about the stack. Uh, I'm not gonna go too in depth into it. I think it's gonna be explained a lot better in the book, and an illustration really helps. But I'll try my best. So we're doing bf1. So cd bf1. Okay. wgets. Come on now. So let's see here. Yeah. And by the way, if you ever run into this problem, you try to run a program says permission denied, it's because you gotta make it green by doing this. And basically you just give it permission to run like that. Okay, so it says please enter your string. Once again, we're checking for a buffer overflow because I mean it's the challenge is literally called that, so it's probably gonna be that. And we see here. Time to return, fingers crossed, jumping to 0x for 1 for 1. So um, basically in this situation, they're giving us an aid by telling us that uh, after this is the return of one of the programs. So this is the at the very end of a function. So in this case, because I mean I already looked at the problem, but the function is going to be vuln. Actually, let's just look at it here. But basically, when it ends a function, there's something called the return address on the stack, and so you set the return address or set the instruction pointer, the EIP, equal to the return address, and that is this value here. So that's why they say they're jumping to that, because the instruction pointer is jumping to that. And the instruction pointer tells the computer what to do. And you can see here, segmentation fault. Whenever you see this, this is like a what's it? This is like a hacker's dream, you know? Because whenever you see that, that's how you know the computer crashed, or not computer, the program crashed, and that's really interesting. It's not interesting if the program doesn't crash, but you know, this is how you know something happened, right? And so they give us the source, so we can just dive into that. Sorry. Oh, unfortunate. Let me do that again. Copy a link. There we go. Okay, so let's have a peep here. Okay, so it's another C program. Flag, blah, 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 blah. We see F gets here. These they made a safe, but we see gets here in the function called vuln. Okay, so that's very interesting. And blah, blah, blah. And we see get return address. So this is the value from which function? Okay, I guess I don't see the function, but whatever, it's fine. So, uh, yeah, basically, vuln is our function of interest once we get into this. Okay, so let's get out of here. And so we're going to use something called GDB. It's a debugger because it's compiled, right? So what we're going to see, we're not going to see clean code like we just saw when we just look at the compiled program or file. We're going to see a bunch of this. And this is assembly. Actually, let's make it a little neater. I like to do this. Intel. So you just type that in. It makes, I don't know, it just seems a lot cleaner. You get rid of these weird symbols. Now you get clean code, right? So here, these are the registers, blah, 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 bunch of instructions. A lot of this, you don't really know what's going on. You don't really need to pay attention to, but because we looked at it before, we know, so these calls mean that it's calling a function, right? And because we looked at it before, we know that vuln is an interesting function. So let's take a peep at what vuln is doing. Okay, so there's another function. So that's the get return address. If we really wanted to, we could look at that. So uh, get underscore return. Okay, very interesting. Uh, yeah, okay. So I don't know what that does, but I'm sure it gives us the return address. I don't think these values are mean anything, but I think this is the only thing that matters. Anyways, see there's a gets here. Gets is our vulnerable function. So just so I can illustrate what's going on the stack, I'm going to set a breakpoint right before the gets, right after the gets, and right before this return, which will set the EIP equal to the return address. And so let's just take a look at that, run it, okay, and let's take a peep at the stack. No, there we go, yeah, there we go. Okay, so boom, stack. Okay, so look at it, nothing, not that interesting. Well, we do know that somewhere in here, there is the return address. So, I don't know which one though, but we can figure it out pretty soon. So now this is the gets. We put in our input. So let's just do regular input. This is not going to overflow the stack. We take a peep again, and then we can see 0x4141. That's ASCII for the capitals A's. So you can see the thing started writing here. Okay. Do it, go again. So we can see we're right at the return. Disassemble main. Sorry, disassemble phone. So this little arrow shows you where you're at. So we're right here. Now we look at the stack. We can see there's this value, and this value is actually the return address. So you can see what I mean when it sets the EIP equal to return address. When we do info registers, we see EIP is this, And then if you go next instruction, so we're going to go past the return, and we set registers is equal to this value, which is that. And also, if you check back at the stack, it's there. So the return address is there, and relative to where we started writing, it's so each of these holds 4. So 1, 2, 3, 4, 8, 3. So that's 11. So that's 44 characters of A. And then we write the next 4. We're going to overwrite the return address, which is this. Okay. And yeah, so we do it again actually. So I'll just show you what happens if we overwrite the return address. So we know that, okay, so you type in a bunch of A's, that's 4. Copy, paste, that's 8. Copy, paste, copy. Okay, just to make sure I don't lose count. So that's 16. 1, 2, 3. That's 44. Sorry, 48. 1, 2, 3, 4. And then we get rid of the last one and put B's there instead. This might look really weird, but you're gonna see. So take a look at the stack. Where is that command? There we go. Okay, so we overwrote our 44 A's, and then the last 4 are B's, which is 0x42 in ASCII. Okay, we go again. We can see they hint at it, but we didn't really need this. It says that the return address is 0x42. Info registers. We can see right now EIP is this. Next instruction. And boom. 0x42 is question mark because it doesn't exist. Or at least it doesn't have any readable values that we can use. And we see EIP equals that. So yeah, basically it's looking for instructions at this address. Nothing is there, so it won't happen. And if we control EIP, we essentially we can do whatever we want. Okay, but where do you want to go once you got EIP, right? And just a little hint for these problems, like 9 times out of 10, there's something called a win function. And guess what? If you call that function, you win. So we know this is going to be at this address. Actually, yeah. I think there's more. If you didn't know it was there, there's other ways you could like deep dive into the program, look for it. I'll say, what was it in the was that in the source code it gave us? Yeah. So yeah, sorry, it was in the source code. Pwin, and then blah blah blah. You see, opens the flag and then it prints the flag. So if we call this function and I copy the address of this function, if we set the return address equal to this at the ret, the EIP was equal to the return address, which will equal this. It calls this function, and then hopefully it will print our flag. Okay, how are we going to do that? Well, a tool that I really like to use is Pwn. Sorry, Pwn tools. It's like a Python module. Um, yeah, so Zim. Actually, what am I going to do? What am I going to do? Yeah, so they have a really beginner-friendly function. You can do template. No, like that. Yeah, yeah, yeah. Vuln. So template's part of the instruction. That's just your binary, and then this is your output file. So, okay. Vim exploit.py. See, there's a bunch of junk. Now, this is really helpful because mainly because of this, you can debug it. Like, you can't use it on this web terminal, but if you had like a virtual machine, or if you just have like Linux or Mac, you could run 2 terminals, and then you could debug it while it's running. But anyways, our main point of interest is here. Let's just get rid of this. So between the IO start and the IO interactive is mainly where we do it. And important functions are IO send line and IO dot receive line, something like that. Wait, hold on. Anyways, so So we have IO with that receive line, IO.send line. These are the two main instructions you're gonna use. IO.receive line is gonna be like, oh, it's just gonna receive the line. So when we ran the program, it was like, please type in your input, whatever. So we do that. We even print that, so it's nicer. And then IO.send line. So we knew that we wanted to type in B's. So B, you're putting a B in front of it makes it into a byte. It's not important now because we're just typing letters, but you'll see later on. B, and because we want the last four to be B's. Okay, that should be good. Python 3 exploit.py. Okay, yep. So we ran it. So here's the please enter your string. That was from our receive line, and it jumps to there. And as we did, as expected. We also see here gives us some information on the binary itself. So um, these are like security measures against kind of vulnerabilities. So for example, we have NX for executable stack, PIE. What's that? That's it kind of randomizes the I think so. It kind of randomizes the addresses. It makes it harder later on, but we don't need to worry too much about that. Yeah. Okay. So I think probably lost the function right now. So let's go back into vuln. So we know how to control the IP. We just need to go to win, right? P-win, and we can find out the address of win. Copy, clear, vim exploit.py. Okay, and another reason why I like pwntool so much is that if you're trying to type in the address by hand, it would take. Sometimes it gets really bothersome because of like endianness and all that. But pwntools, you don't need to worry. Just type in P32. We know this is a 32-bit because the registers are like EIP, ESP. If it was like RIP, RSP, that's 64-bit. And there's other ways to tell, but that's kind of one of the easier ones. Okay, so basically, to summarize what we're doing, we're gonna keep typing a bunch of A's, and then once we get to the return address, we type in what we want the return address to be. Okay. Python 3 exploit.py. Boom. So we see we jump to win, and it's complaining because there was no flag. Perfect. If we make a flag, hello, this is the flag. What is that? Control X, Y, answer. Run it again. Hello, this is a flag. So if we had a flag, it would print it. And yeah, because this is running locally, right? Now we gotta do this, apply this to the netcat. We don't use it because we have pwntools. We don't actually need to use the netcat. Anything I'm missing here? No. Okay, so we just need this. And we do vim exploit.py. So here, what was it? Yeah. No. We go down here. So instead of IO equals start, we just replace this I equals to remote, and we just paste in what we need. And this is like my usual setup. Usually every problem I'll just do the same thing, template, boom, replace, and then after I solve it locally, I just replace that and put remote. I think binary exploitation is a lot about just like finding out what works for you, like what's a good setup, and yeah, and then you just work from there. Okay, so we have iOS remote, Saturn return. Yep, it should be good. And then and there. So we got the flag. Okay, now we paste it in. Submit flag. Boom. We solved it again. Yeah. So I think I'm gonna end this video here. Thank you everyone for watching. Uh, hopefully hopefully this helped you guys. Please let me know, anything I could do better, anything I didn't explain too well. Was I rushing? You still like my voice? Am I talking too quickly? Anything like that? I'm kind of new to this kind of thing. And if you're part of the club, hopefully some other members can start making their own videos because binary exploitation is kind of the only one I know. And well, I'm not exactly an expert at it. But yeah, thank you. Take care.